Okay, so we've taken a fair amount of load off our database. Now, if we were to go through that whole solution, we'd only be doing database writes, and we'd very rarely be doing a database read at all. And this is a big improvement over doing a database read on every page view. So let's go back to what our request does. On every request, remember, we process the request. You know, this was HTTP URLs and all of that stuff. We did the DB query, the database query. We collated the results, which for, you know, ASCII-chan or the blog there's not really much involved in that at all. And then we rendered the HTML. So we've improved the database query, but what if we want to improve these other pieces? You know, we can use caching to render HTML. That's definitely a technique there. And we can actually use another technique on handling all three of these parts of the request, which is adding additional app servers. And this looks something like this. To date, conceptually, we've basically had one program running that handles all of our requests in your blog and in ASCII-chan. We've got this simple program. You know, requests come in, responses come back out. But if we have so many requests that one machine can't handle it, what we can do is we can add multiple machines to take up some of the load. And so all these extra requests can go to all these machines, and these machines, you know, may be interacting with the database. They may not be. You know, presumably they have their little caches that we just implemented that lives in our program. And this helps. So how do we get requests to multiple machines? Well, there's a piece of technology that sits between the user and all of your app servers called a load balancer. And this is a special machine. It's a physical machine, just like your app server might be, or just like your database server might be, that's optimized for doing one thing, for spreading requests across multiple machines. So what happens is this load balancer has a list of all of the app servers that are in existence, and requests come in from the outside world, many of them, and the load balancer decides which app server to send the request to. Send one here, then send one here, then send one here. And it can keep going through that process. And the reason this load balancer can handle all this traffic while the app servers can't is the load balancer isn't doing anything other than taking in the request, choosing a server, and forwarding the connection along. It doesn't have to parse HTTP, or it may only parse minimal HTTP. It doesn't have to, it's not doing database queries, it's not rendering HTML, it's not going to the cache. It's doing almost nothing at all, other than deciding which server to send a request to. You probably won't ever have to write one of these, but it's good to know how they work. And when you're using App Engine, Google kind of does all this for you. They'll automatically create new servers running your program and scale it. You can actually go into the App Engine admin page and see how many servers they're using to host your app, which is pretty cool. Normally, this is a really challenging thing. And not knowing how to do it the first time, this took me a little while to figure out when we were scaling Reddit. That doesn't mean I'm not going to make you understand these things a little bit deeper. So there are a couple algorithms a load balancer can use to determine which server to send traffic to. The simplest one is probably just to randomly choose a server. You know, a request comes into the load balancer, and the load balancer just picks a server and sends the request there, which will, you know, probably work pretty well. You know, over time, if you have enough requests, each server should get about the same amount of load. Another approach is round robin, and round robin just means the load balancer is going to choose one server at a time. You know, first this guy, then this guy, then this guy, then this guy. You know, just in order. That's also a fairly simple algorithm. And then some load balancers are really smart, and they know what the load is on each server, how many requests are outstanding at each server, and it may use some sort of load-based algorithm to say, you know, this guy's already handling like 5 requests, and this guy's not doing anything, so let's send, you know, future requests here until, you know, things even out. There's lots of approaches to doing this. What I'm going to ask you to do now in the form of a quiz is implement a basic round-robin algorithm.